Alright, so, I kind of didn't want to keep doing these, um, making these videos. I thought it was kind of fun. Um, it makes me feel kind of vain in a way to do them, I suppose, but I'm going far enough down the rabbit hole of like just doing all this kind of like stupid documentation and stuff that nobody really cares about. So I figured now that I know how to make a video and stuff, maybe I'll just keep doing it because it can be kind of fun. Sometimes it's kind of interesting for me to go back and watch them. So I think I might just do that every once in a while, and then I don't know. Maybe let people know if I post them. Maybe not post them at all. But you know. So I figured what I would do is let's see. The date today, just by the way, is July 16th, 2022, and so Um, what I'm going to do is do a little bit of development on a new feature. Guardian was talking to me yesterday in the chat about having a new UI element, which I thought sounded pretty good. So um, I'm going to do that a little bit. Um, I've started working on it a little bit, so I'm not going to just start from scratch with it. But I don't think that it's really a super major kind of feature, so it shouldn't be that difficult to do, probably. Um, but anyways, I'll just show you. I made a ticket for it, so we can look at that. Um, so basically, the idea behind this new UI element is kind of a way to dynamically build queries. Um, because in, let's see, I think part 5 of the tutorials that I made, I talked about doing complex queries and simple queries kind of in sequence with each other in Tagger. And Guardian mentioned that it might be kind of useful to have sort of like an undo button or um, a way to, you know, maybe if you make a mistake in one of your queries, like if you run a handful of simple queries kind of in succession, it might be useful to have a way to undo one of those or something, which I agreed with. That's kind of um, it is kind of annoying to start over from a query if you make a mistake. Um, so that might be kind of, you know, something nice extra to have. I don't really think that most queries ever become more complicated than like one or two kind of simple queries. Excuse me, but it might be kind of nice to have, and it's kind of something else for me to work on, I suppose. So anyway, here is the ticket that I made for it, right? So basically what we want is a UI element that as you write a query in the query bar in Tagger, and I'll pull Tagger up so we can kind of talk about it a little bit. Um, as you write a query in Tagger here, so you know you just search for cute like that. That's always the first one that comes up, right? There, that's a good one. So when you write that, you know, cute query in, what I had in mind, I don't know if this is the same thing as what Guardian had in mind with it, but you would have this kind of, you know, maybe box that had your query show up above this, so it would have some information about that query, like what the setup was when you did it. So like it would say like union cute, so it would look, you know, it would look like this. Just imagine a little box that has this text in it like that. And then, you know, in addition to that, it might show all the affected files by that query. So there would be a number next to this that would say like 603, like there's 603 files that would be returned by that query. And then, so just imagine we've got that little box floating above here. And then, you know, say, oh, I want to see, you know, how about only cute characters in idle outfit, right? So then we want to change this to an intersect. And then just say, how about only in their idle outfit? So we do that. Right, and then there would be another box, so it would be kind of like the cute box would get pushed up one step above, and then you would have one that looks like this here, idle outfit, and then you know you'd have some number. I don't know how many files there were in there, um, and then you would have some number. So you'd have this box underneath the cute one, and that would give you kind of a visual history of your query. But then something I think that leads logically from that is that right now we have this file selection, which is a result of this whole kind of series of queries that we've done. But the actual file set and queries that we've run are kind of divorced from each other, right? It's like it's a cause and effect thing. So this file set exists after the queries exist. But what I thought was really kind of, I don't know, maybe this is just me being kind of silly or kind of stupid. But what I thought was pretty compelling about Guardian's idea is that it's a more declarative approach to tagger queries, which, having written this in Haskell, I find to be pretty appealing, right? So that would essentially kind of remove this cause and effect relationship and just have and change it to be like just an is relationship, right? So that the query that you see here and the files that you see here, even though implementation-wise it may be the same thing that we have right now, it has a more declarative concept behind it so that they become the same thing, right? And so what I would like to change about the implementation with that to kind of reflect that change in concept is that, if you do like a Control R or you refresh this selection, nothing happens, right? Because we don't rerun any queries. Because like I said before, this file selection is its own thing. There's no query associated with it. It's just files that we have in memory. But what I want to change with this new change is when you refresh the UI, it would actually successively run all the queries again, right? And so that would mean that all the files in here and the queries here are both the same, and that when you refresh the UI, it reruns the query, which maybe performance-wise and stuff like that, it might, not necessarily be ideal, but I think conceptually and implementation-wise, I find that to be kind of a compelling idea. So I think that I'm going to do that, and then that's kind of the gist of the UI here. So we'll kind of talk about some of these bullet points in this ticket. So, right, we have that list of widgets, list of queries in the UI, and then so what I would like to be able to do is also dynamically edit that list. So like Guardian mentioned, if you made a mistake with one of the queries, you should be able to delete that query from the list so that when you refresh, it doesn't run that section of the query, right? So if I wanted to undo my intersection, I could just go and delete that node and then rerun, and then it would basically just query for cute all over again, right? Instead of intersecting with idle outfits, which I think is a really good idea. I don't know if Guardian necessarily had this in mind, but I think that you should be able to edit parts of the query. I wouldn't want you to be able to edit the actual terms in a query, like change something from cute to a different descriptor. But I think that you should be able to change at least the set operation so that you can change how some certain things are combined or whatnot. It's kind of a minor thing, so maybe I'll just say that that's a stretch goal retroactively instead of doing that. One thing I definitely want to be able to do for sure is reorder queries, right? Because you saw that in the tutorial video, I spent some time trying to figure out why one of the queries I was writing wasn't working, and that's because that I grouped things. I ordered query terms incorrectly, and so that's why it was doing something I didn't anticipate it to do. So it would be nice to be able to reorder query steps and kind of retroactively fix whatever kind of broken query you made, right? Another thing that I think this would help is to just be able to understand visually how Tagger runs queries. It really is very simple, and in the UI, like, it is just a list. The actual syntax tree for a Tagger query is here in this file. So like the top level query is just a new type, but it's just a list of things, right? So it's the exact same thing that we would do in the UI, is just have a list of things, which is very simple. But Going lower than that, we have this tree here, which is made up of just a simple node, or it's made up of a list of itself, right? But we don't really even have to think about it recursively like that, because we really only care about each of these components, so it's enough to just have a list of these, which is exactly what I'm going to do. So I don't know, this bullet point isn't really super necessary, but it might just be kind of helpful to know, like, it's in abstract syntax tree, and it does have kind of a tree structure, but at the end of the day, it all just turns into a list, and that's how the query engine handles it. Is it goes through a list, right? So it just goes one by one. And then let's see, this bullet point is, like I mentioned before, it's just conceptually more of a declarative way to query for taggers. So and then let's see, so I also mentioned this too, is that for each of those query sections, we want to be able to see the number of files that are affected by each node of the query, which I think would be pretty simple to do, and I'll talk about. I think I already have an implementation for that I'll show in code here in a minute. And then just here's some stretch goals, like just save a query so you can use it as a view. I don't really think that's super important, so I might just never do that. But if you can save something, you should be able to import something, even if that's just having a text field, which I suppose is just your query bar. So, you know, maybe these are already done, right? Those are already complete, so that's cool, right? Let me see how long this is getting. Okay, I might stop at like 15 minutes and then decide if I want to do more of this, but excuse me. So here's just a simple module I made. Already started working on this. I made a new module just because I think it might be good to kind of just encapsulate this, because I had to make a couple of new types to handle this, how it's implemented on the UI. So I mentioned before, when you run this Qt query, what we see visually is only one term here. So when I say term, I mean a term is a construct inside the abstract syntax tree. So I'll just start at the bottom here. So we have this, close that. This word cute is a term, right? And so here in our syntax tree is a term. This is the simplest and smallest unit of a syntax tree, and so we can see that a term has a query criteria and it has a pattern, which is our A. In this case, the A is a text, right? And I have these types parameterized just in case I wanted to traverse the tree or map the tree or something like that. In practice, this is almost always a term text, or maybe like a term with a hash set of files or something if I want to run a query on a term. That's really kind of irrelevant. Just imagine this A is just a text, right, or a string. So this here is a term, and then it has an implicit query criteria, like I mentioned. It has an implicit R dot for relation criteria. And so when this runs through the parser, this term actually gets transformed into one of these bottom terms. And then in the next level of the parser, where we create a term tree, any bottom terms that are top level, like that aren't in a subtag query, like this Qt would be a bottom in here too. Any term that's not in a subtag query but still a bottom, it simply gets lifted to a simple term. So this might be really kind of confusing or nonsensical without really understanding, knowing, or caring how the parser works at all. It's a little weird how it works in implementation, but everything by default is a term that then gets parsed to a complex term, and then depending on where those complex terms are in the query, they may be lifted to a simple term. So they get lifted outside of their type to a new type, and then those all get combined in this new sum type term tree, where you have either a simple or a complex term. And then those term trees, they just get kind of wrapped in a list. This new type sentence is just a list of term trees. And then here we have a sentence set, which is this this intersect and then cute as it is right now would, in a way I suppose you could say that it would be kind of desugared into this. And so this query right here is a sentence set. It has a set operator right there, and then it has a sentence, which is this cute, right? It's a list. We have a list of one term tree, which is this r.cute. This term tree is a simple, which is just a simple term, which is just a term, which is this r.cute, right? So that's kind of how the parser works. So we have this sentence set, and then from sentence set we'll lift things into a sentence tree, where you can have either a sentence node or a sentence branch, which is a recursive structure. And so the sentence branch is the syntax tree version of having these nested queries in parentheses. And so this this here, as we saw, is a sentence set. When this gets parsed as a sentence tree, it just becomes a node, right? Because this isn't a query, it's not a it is a query, but it's not wrapped in parentheses, right? So there's no grouping, there's no precedence, it's just a node, right? But say like if we had let me think of the example that I used the other day. Like that, and then right, so that's not very helpful to see, is it? Hold on. Okay, so like this query here, this would have sentence branches in it. So each one of these, this here is a sentence branch, this here is a sentence branch, and then this here is, I believe, actually is just a list of sentences, right? But each one of these parenthesized groups is a sentence branch. So you can see, because this is recursively defined, this has a list of sentence trees, that this sentence branch contains this sentence branch, like so, right? And then this query here is just a sentence node. Each one of these in here is a sentence node. That's a sentence node, but they're contained in sentence branches. And then the request is just a list of sentence trees. So the actual request here, the parts of this request that we see, this is one part, and then this is another part. So this top level request would actually be this query would be parsed into a list of only two items, this item and then this item, right? And the reason that I kind of gave that little walkthrough here is for this UI, what we want to do when we display each of those query components, we want to display a sentence tree, I believe. I'm trying to think, actually. Yeah, we want each of those nodes to be a sentence tree, and then when we rerun the query, what we're going to do is then just combine them all into a request like this, right? So we have this list of UI elements that's a list of sentence trees, and then when we rerun the query, we can see that a list of sentence trees is the exact same as a request, right? Because if you're familiar with Haskell, this request is just a new type wrapper for a list. And so if you're not familiar, a new type is a zero cost abstraction in Haskell. All it is just a type wrapper, right? So we define our type, and then it has a data constructor, and that constructor consists of exactly one field. And so what it allows you to do is to wrap types up in other types, maybe to derive type classes, or just to make some things more type safe, because these types are checked by the compiler, but they don't exist at runtime. And so that's why it's a zero cost abstraction. So we can define this new type, but it doesn't actually exist in the program when it's running. And so a little tangent, but that's why I can say that this UI list of sentence trees is a request, right? Because it's a new type. It's just a list of trees. And so maybe spending a little bit too much time on unnecessary implementation stuff. We can talk about the actual UI implementation of this, right? And so this is just the back end. None of these things appear in the UI. This is just how the parser works and organizes a query. So what I want to do is have UI representations of some of these tree components here. But I don't want to use these actual tree components. I want to make new types, right? So I have some more new type wrappers in here, which new types are great. Really good idea to use these, honestly, kind of, I feel like, as often as you can. Really helps with, I don't know, just type checking, make things more sane and logical, I think. So I really like using them. So we make a new type wrapper for a sequence of sentence trees, right? And so it's not, and I call this a widget query request. I would call it a widget request, but in my UI library that's already a type, so I don't want to have that kind of name shadowed like that. So I call this a widget query request, because that is going to be what this UI element is it's a widget query, right? So we can see that this is a sequence of sentence trees. I think actually what I might do before I get into this is I'll probably just end this video here, because this is going to be a little bit talking about this stuff, and I might just take a little bit of a break. But for now, that's kind of an overview, really, I suppose, on what I have planned upcoming, and some of the things that I talked with Guardian about for this UI. A quick overview of the query language's syntax tree. Hopefully it kind of makes sense. If not, that's alright. It's really not important to know about how the syntax tree works at all. And then, yeah, maybe next time, if there is a next time, I'll talk about, the implementation details of this new UI element I have planned. So, thank you.